How's it? I guess it's time for me to give my GSSA talk. It's always a pleasure for me to speak to the annual Congress, although it's a little odd to be doing it from my living room this year. The conference actually comes at a pretty good point after having watched all of last season's rugby reruns. I don't care how many cases of COVID-19 New Zealand doesn't have, we still won the World Cup. Speaking today about drought and livestock production in rangelands and how prescribed fire can be used to mitigate some of the effects of drought. Drought is certainly nothing new to rangeland ecosystems. There hasn't been a lot of discussion about how we might be able to use discrete patch burns as a means to mitigate the negative effects on forage production caused by drought. Colleagues down in Oklahoma in the southern plains showed that during drought periods, cattle gains were buffered when the cattle were grazing on areas that had been patch burned. Those data are from much further south, and this whole pattern has yet to be described up here at the northern part of the Great Plains. My colleagues and I at North Dakota State University started 2 patch burn grazing trials at 2 locations in North Dakota in 2017, which just happened to be a particularly bad drought year. So it was bad enough that we were trying to use prescribed fire in rangelands in a part of the country where prescribed fire just really isn't an accepted practice among private landowners. We were trying to do this in a particularly bad drought where people were thinking, why are you out there burning this forage that you're potentially going to rely on later in the season? We did it anyway. When all of our animals did in fact survive, we were able to compare their performance during the drought year to other conditions, such as the previous year when there was normal rainfall at one of our locations, and at the other location we actually had no fire control where we just had season-long continuous grazing and our recently started patch burn pastures. So we could compare those 2, patch burning and no patch burning, within the same year just across the fence, and at the other site we were able to compare patch burning in the drought year versus the previous year, stocked exactly the same, but no fire and normal rainfall. I will take you across the ocean to North America, where we're going to talk in the Great Plains, which is bounded by this purple line here. We'll zoom into North Dakota to the Central Grasslands Research Extension Center. Central Grassland is a relatively humid location in central North Dakota. You can see that our drought set in June at the beginning of the grazing season, and by the end of the grazing season with no rain in September, we were 100 millimeters below the 25-year average. Here we have patch burn grazing treatments and 4 continuous grazing treatments without fire. It's pretty cool that our burns show up on a satellite. Let's take a look at how we did that. We do our prescribed burns by putting a mineral fire break between our patches. This is mostly native mixed grass prairie. We have 2 treatments with 4 reps each. We have 4 reps with 11 hectare spring only burns. And then we have another 4 reps where we have 5 hectare spring burns followed by 5 hectare summer burns. The idea being if we can stimulate high quality grass regrowth, we might be able to extend our grazing season. Because this is the first year of the experiment and only 1 patch has been burned, everything else will be referred to as not yet burned, and all data will be shown in this color in subsequent graphs. Likewise, the burned area will be shown in green in subsequent graphs. We sampled both the burned and not yet burned areas several times through the grazing season by returning to the same fixed points. At each point we laid a quadrat from which we clipped all standing biomass and also counted all the livestock poop around that area to determine grazer space use. We used NIR to determine the forage quality. Assuming you have a colleague that has one, this is a relatively cheap means to get a lot of different response variables. We simply grind the samples and put them in the machine and then use a calibration curve. Let's go now to western North Dakota to our semi-arid site near a town called Hettinger. Hettinger generally has less rainfall than central grasslands. Our focal year was well below the 25-year average, whereas the previous year was pretty darn close to that, making a good year-to-year comparison. We have 6 patch burn grazing pastures with cattle and sheep. Here's a block, and we can go down and see how we did one of those fires as well. The study design out here is quite similar. We have the same mineral fire breaks between our patches. You can see they're fairly wide here. We use a ring ignition to burn 11 hectare patches, a 1/4 of our pastures, so we can affect a 4-year fire return interval. We're only comparing one size of patch. In Hettinger, we have the sheep and cattle comparison with 3 reps each. Despite differences in the treatments, all were collected at both locations in the same way, and we returned to each point monthly throughout the grazing season. This slide represents the main take-home point of this study. Despite starting our prescribed fires during a drought year, livestock performance at both locations did not suffer. At our semi-arid locations, where we compared our drought year with a fire to the normal rainfall year previously, calf weight actually increased, sheep weights were about the same, and cattle weights had no significant difference. At the central grasslands, all cattle on patch burning pastures had significantly positive weight gains despite the drought, whereas on the continuously grazed pastures without fire, there was a trend towards losing weight over the grazing season during the drought. One reason that livestock might have done better on the burned areas despite the drought is that the crude protein content of forage in the burned patches was greater throughout the grazing season. While this contrast wasn't quite as extreme at our semi-arid location, it was very clear at the central grasslands. Based on dung density at both locations, it is clear that all livestock had a very strong preference for burned patches throughout the grazing season. Long story short, even though some people thought it was crazy for us to initiate our prescribed fires in a drought year, by the end of it we actually found that our livestock had performed better. Because we're just comparing the end of season weight to the beginning of the season weight, even with sufficient backgrounding at each weighing period, we don't know what happened with the weight fluctuations during the season. It's interesting to think about why the animals that were on these burned areas didn't lose weight. The burned areas weren't particularly large, but we can see that the crude protein content was consistently higher than the other areas of the pasture throughout the grazing season. Of course, crude protein alone is not a singular measure of forage quality. One great thing about our data is we can get a broad spectrum of all the components of forage quality, and we have analyses coming up that are going to look at a more holistic picture of forage quality and not just crude protein. We also have GPS collars on our livestock, so we can see when and where livestock are using pastures at a much finer resolution, both in terms of space and in time. One of the things that really stands out to me, though, about the spatial distribution through time, as we saw, is that we didn't see the animals spend much more time in the unburned patch even as the drought progressed. Going into this, one of the reasons why we would have expected the patch burn grazing pastures to buffer animals against weight loss despite the drought is that the unburned areas could serve as stockpiled forage or a grass bank to which they could go and get additional forage if the productivity of the burned patches declined. However, in this case, we didn't see the animals using the unburned areas at greater frequency as the drought progressed, which suggests that the burned patches were able to keep up with the forage demands of the animals with high quality forage throughout the grazing season. This bodes well for other aspects of the ecosystem in that cattle aren't going into the unburned areas and reducing the quality of those areas for wildlife that require dense vegetation, and then they're not also eating the vegetation that we're going to count on for fuel to burn next year to ensure that we can keep the shifting mosaic of the patch burn grazing pattern going next season. Thank you very much for this opportunity to participate in the Congress from afar. Thank you. Bye, donkey. Bonga.